Okay, so our last section in trigonometry, the cosine law. So the cosine law describes the relationship between the cosine of an angle and the lengths of the three sides of any triangle. And once again, we use the cosine law when we don't have a right triangle. Okay, so we don't use when we can't use SOHCAHTOA, then we would want to either use the sine law or the cosine law. Okay, so for any triangle ABC where A, B, and C are the lengths of the sides opposite to angle A, angle B, and angle C respectively, the cosine law states that C squared equals A squared plus B squared minus 2AB cos of C. You can express the formula in different forms to find the lengths of the other sides of the triangle. So if I want to find side A, then I would go A squared equals B squared plus C squared equal minus 2BC cos of A. And if I want to find side B, I would go A squared plus C squared minus 2AC cos of B. Now on the formula sheet, you're only ever going to get one of these formulas, and it will most likely be this middle one here. So it would be to your advantage to recognize the patterns between all of these and how you can come up with the ones that will find the other two sides. Okay? Or of course you could just take your diagram and relabel all the sides so it suits your formula. Okay? But just so that you can see some patterns here. If I'm looking for side C, then I'm going to square the other two sides and I add them. So A squared plus B squared minus, and then A times B, which are my two other sides, multiplied together, times the cos of C, so the angle opposite the sides that I have over on the left. If I'm looking for A squared, then I would go B squared plus C squared, the other two sides squared, minus 2 times B times C, so B times C, cos of A. And A being the side opposite the side A being the angle opposite the side that I'm looking for. And then if I wanted B squared, I would go A squared plus C squared minus 2AC cos of B. So the two sides squared that are not B, minus 2 times A times C, and then cos of B. So if I was going to do this, and let's say on a formula sheet I have A squared equals B squared plus C squared minus 2BC cos of A. And let's say I wanted to find C squared. So I would go, all right, well, C squared equals, and then I would square the other two sides I don't have and add them. Okay, so I'd keep the same format as this formula. Minus 2, instead of going B times C, it would be A times B. And then cos of C, which is opposite the side I want. Okay, and then if I wanted B squared, I keep the same format as these. I'd square the other two sides that I don't have. So A squared plus C squared minus, and then 2 times A times C, and then cos of angle B. Okay, so you don't have to memorize the formula because that'll be on the formula sheet, but you would want to know how to come up with the other two. Okay, or like I said, you would want to just rearrange your letters on your triangle. Okay, now before we go over the table, I just want to show you how you can manipulate the formula to find an angle. So let's say that I want you to find angle, or let's say you want to find angle A, okay? So you would want to use this version of the cosine law. And because you want angle A, you would want to solve for cos of A. So we would want to solve for cos of A. Okay, so what I would do then, because I want to isolate this to start with, I would take my B squared and my C squared and I'd move them to the left. Okay, so I would get A squared minus B squared minus C squared equals negative 2BC cos of A. And then because I want to isolate cos of A, I would divide both sides by negative 2BC. And so this will reduce. Okay, and what I will have then is that cos of A is equal to A squared minus B squared minus C squared over negative 2BC. But I don't want the negative in the denominator. Okay, so what I would do, I would take the numerator, I'd pull out a negative, which would make my A squared negative, right? Because a negative times a negative would bring me back to a positive A squared, and then this would become positive and this would become positive, and so then I can make a negative divided by a negative a positive, right? And so the cos of A is equal to, and I'm going to go B squared plus C squared minus A squared over 2BC. And of course there are the other two versions. If I want cos of B, then I would go A squared plus C squared minus B squared over 2AC. And then cos of C is equal to A squared plus B squared minus C squared over 2AB. Okay, and once again, there are patterns here, all right, that you could use to help you remember the other two formulas. Now, this version of the cosine law will not be on a formula sheet, okay? So if you want to use it, you can memorize it, which I would recommend, because if I'm looking for an angle, it's easier to use this. But you don't have to, because you can always use these versions to come up with your angle. You're just going to end up having to do some more isolating, that's all. Okay, so when do we use the cosine law? All right, well, let's go back to congruency conditions, okay, which we were looking at with the sine law. And we've got two other situations. And in both of these cases, you would want to use the cosine law. So let's say that you are given two sides and an angle which is contained. That means that that angle is in between the two sides that you are given. Okay, so now you have side, angle, side. That's your congruency. Okay, then you would use the cosine law. Okay, so if you've got two sides and a contained angle, then you would use the cosine law. Okay, and the second situation would be if you were given all three sides to your triangle. Okay, if you're given all three sides to your triangle, then you would use the cosine law. So that would be side, side, and side. Okay, so in the first situation, you would most likely be looking for a missing side, and on the second situation, you would be looking for a missing angle. Okay, so I will end this discussion here, and then on the next video we will talk about proof. Okay, so we're going to take a look at how we derive or where the cosine law comes from. Okay, so we're going to start with triangle ABC and draw an altitude in it, or the height, which we'll call h. So here's the height. Okay, and notice that opposite side angle A is side A, opposite angle B is side B, and opposite angle C is side C. And by drawing in the altitude, we have two triangles. We've got BCD and we have BAD. We're going to have to relabel the base, or the bottom of our triangle, okay? And if I call from C to D x, then from D to A, I'm going to call it B minus x. Okay, and if you're not sure why that's true, let's say that x is 4. And let's say that B is 10. If I want to figure out the distance from D to A, knowing that x is 4, so this side is 4 and the whole thing is 10, to get from D to A, I would go 10 minus 4, okay? Or in this case, B minus x, all right? So that's why from D to A is B minus x. Okay, so for triangle BCD, I'm going to come up with two expressions, okay? The first one, we're going to look for cos of C. So we're looking at this angle, and in triangle BCD, X is adjacent to angle C and A is the hypotenuse. And so the cos of C is adjacent over hypotenuse, so X over A. And I'm going to solve for X, so I'm going to multiply both sides by A, so we reduce the A's on the right, and so we are left with X is equal to A times cos of C. Okay, so we'll be using that. And then using the Pythagorean theorem for triangles BCD, I can say that the hypotenuse squared, so A squared is equal to H squared plus X squared. Okay, so we're going to use this later. Okay, now in our second triangle BAD, okay, using the Pythagorean theorem, I can say that the hypotenuse squared, C squared, is equal to H squared plus B minus X squared. Okay, and then I'm going to square the B minus X. Alright, so I'm going to go B minus X times B minus X, and I'm going to get B squared minus 2BX plus X squared. Okay, so that's what this is. Alright. Alright, so then I'm going to go over to the left again, and I'm going to see if I can do some substitution. Alright. First of all, I know that H squared plus X squared is equal to A squared. Okay, and I have an H squared plus X squared here, so I can replace that with A squared. Okay, and then the other thing that I want to do is I know that X is equal to A cos of C. Okay, and so notice that you have an X here, and that's equal to A cos of C. So I'm going to substitute into there. Okay, so what I'm going to do, I'm going to replace H squared plus X squared, which is over here, with A squared. Okay, so that's replaced with A squared. Then I have plus B squared minus 2B. And then in place of X, I'm going to put A cos of C. Okay, so I'm going to get 2B times A cos of C. So when everything is simplified, you're going to get C squared equals A squared plus B squared minus 2AB cos of C. Alright, and there is your cosine law. Okay, that is our discussion on the proof. Okay, so we're going to take a look at our first example where we will use the cosine law to determine the missing side of a triangle. And once again, you will want to know whether you're going to use the sine law or the cosine law on any triangle that's not a right triangle. And so the information that we have on this triangle is that we're given a side, an angle, and a side. So that would be side, angle, side. And if you go to your chart on the first page, you will see that when you have a side, angle, side, you would want to use the cosine law. And another way to think of it is that you have an angle which is contained between two sides, or if you like, situated between two sides. So it's in between the 22 and the 31 that you find the 135-degree angle. Okay, so we're going to find X in this triangle to the nearest whole number. Okay, and we need to label our triangle, so I'm going to call my 135-degree angle A, and then I'll call this B and C. And so opposite angle A is side A, opposite side angle C is side C, and opposite angle B is side B. And I'm looking for X, which I've labeled as side A, so the version of the cosine law I'm going to use is A squared equals B squared plus C squared minus 2 times B times cos of A. And so in place of A squared, I'm going to put X squared, because that's the side I'm looking for, and then B squared is 31 squared, and C squared is 22 squared minus 2 times 31 times 22 times the cos of angle A, which is the cos of 135 degrees. And so I'm going to plug all of that into my calculator. So I'm going to go 31 squared plus 22 squared minus 2 times 31 times 22 times cos of 135 and enter. And then I find that x squared is equal to 2409.49365. But I want to find x, so that means I need to take the square root of 2,409. So I'm going to go second x squared to get me my square root, and then second negative sign because that's second answer, and then enter, and the square root of 2400 is 49.0865, and so on. And so my value for x, the missing side, is 49 units. Okay, so that's to the nearest whole number. Okay, so now we're going to take a look at example 2, where you have been asked to determine an angle. And we're going to use our Lionsgate Bridge to work out a problem. So the Lionsgate Bridge has been a Vancouver landmark since it opened in 1938. It is the longest suspension bridge in Western Canada. The bridge is strengthened by triangular braces. Suppose one brace has side lengths 14 meters, 19 meters, and 12.2 meters. Determine the measure of the angle opposite the 14-meter side to the nearest degree. Okay, so here we have a triangle that is side, side, side. Okay, which means you're going to use the cosine law. And this is side B, this is side A, and this is side E. And you want to determine the measure of the angle opposite the 14-meter side to the nearest degree, which means that you want to find angle C. Okay, so if I want to find angle C, then I need to use the version of the cosine law that will give me, will ask me to use the cos of C. So that's where C squared is equal to A squared plus B squared minus 2AB cos of C. Or if you memorize the formula that would solve for cos of C, you would use cos of C is A squared plus B squared minus C squared over 2AB, which is the one that I'm going to use. Okay, so I want the cos of C. That would be A squared, which is 19 squared, plus B squared, which is 12.2 squared, minus C squared, which is 14 squared, all divided by 2 times 19 times 12.2. Okay, so I'm going to put that in my calculator. And I'm going to put the numerator in brackets and the denominator in brackets. Okay, so I'm going to go bracket 19 squared plus 12.2 squared minus 14 squared divided by bracket 2 times 19 times 12.2, and you get 0.67696. Okay, so that means cos of C is equal to 0.67696. 0.67696 dot dot dot. Okay, so I want angle C. That means I want to use the inverse of cos. So angle C equals to the nearest degree. Okay, so I'm not going to clear anything on my calculator screen. I'm going to go second cos to get my inverse cos, and then second answer, and then enter, and I get 47.393 dot dot dot. Okay, and so the measure of the angle opposite the 14-meter side is 47 degrees to the nearest degree. Okay, and so that concludes examples 1 and 2. Okay, so our last example for this unit and for this section, example 3, solve a triangle. So we are given that triangle ABC has a side length for A of 56, a side length for C at 47, and an angle B which is 124 degrees. You've been asked to sketch a diagram, determine the length of the unknown side, and the measures of the unknown angles to the nearest tenth. Okay, so let's draw our triangle. So I have this. I know that B is 124 degrees, so that's my obtuse angle. And this is A, and this is C. Okay, opposite angle A is side A, which is 56, and opposite angle C is side C, which is 47. So you're going to be looking for angle A and angle C and side B. Okay, and this is a side angle side, so you can use the cosine law. And I'm going to start by looking for side B. Okay, because you don't really have enough information yet to find a missing angle, because in order to find a missing angle you need to have all three sides to your triangle, and we don't have that. So let's start by looking for side B. Okay, so the version of the cosine law that I want then is b squared equal to a squared plus c squared minus 2ac cos of b. So b squared is equal to 56 squared, right, because that's a, plus 47 squared, because that's c, minus 2 times a, which is 56, times c, which is 47, times the cos of angle b, which is cos of 124 degrees. Okay, we're going to put that into our calculator. So we're going to go 56 squared plus 47 squared minus 2 times 56 times 47 times cos of 124, and that gives me 8288.5914 dot dot dot. And so square rooting 8288, I'm going to go second x squared and second answer, and I get to the nearest tenth 91.0417. Okay, but to the nearest tenth, that's 91.0. Okay, I'm going to keep those decimal places in there though, because I'm going to use them to find other parts of my triangle. Okay, so I know that side B is 91.04170 dot dot dot. Okay, so now I've got three sides to my triangle. so that means I can find a missing angle, and it really doesn't matter whether I find angle A or angle C first. Okay, so I'm going to find angle A. Okay, so I'm going to use the version of the cosine law that looks for cos of A, and that's equal to b squared plus c squared minus a squared over 2bc. So cos of A is equal to b squared, which I'm going to use my form of side B that has lots of decimals places. Okay, plus c squared, which is 47 squared, minus a squared, which is 56 squared, and all of that over 2 times 91.0417 times 47. Okay, so when I put this into my calculator, I'm going to make sure that this is in a bracket in the numerator and the denominator is in a bracket. Okay. Okay, so bracket 91.0417 squared plus 47 squared minus 56 squared, close the bracket, divide it by 2 times 91.0417 times 47 bracket, and that gives us that cos of A is equal to 0.860208, and so angle A is equal to the inverse cos of 0.860208, and so angle A is equal to, so let's work that out. We're going to go second cos, second answer, and I get 30.66005 dot dot dot. Okay, which we're later going to round off to 31 degrees. Okay, so on our diagram, angle A is 30.66005 dot dot dot. Okay, so now we're going to find angle C. So this is step 3. Find angle C. All right. And we know that that is just 180 minus 124 minus 30.660054 dot dot dot, and so angle C is equal to, so I'm going to go 180 minus 124 minus second answer, and I get 25.3399, which when I round it off is 25 degrees. Okay, and so angle C is 25 degrees. Okay, and I can round that off now because that's the last calculation that I have to make. Oh, sorry, I need it to the nearest tenth of a degree, so it's 25.3 degrees. 0.3. Okay. So my answer is that B is equal to 91.0 to the nearest tenth. Angle A is equal to 30.7 to the nearest tenth. And angle C is equal to 25.3 degrees to the nearest tenth. Okay, and that ends this discussion, but I'll just change this down here to 31.7 degrees. Okay, and then we'll do our last example on the next video. Okay, so this is a your turn. It's not really an example, and I wasn't going to do it initially, but I will do this with you. You have all the answers here, so you might want to try it out on your own. So anyway, let's get started. I'm going to start by looking for angle S, okay? And that means I might want to just relabel this. I'm going to call this A, B, C, and so this is A, B, and C. Okay, so I want the cos of A, which is B squared plus C squared minus A squared over 2BC. So cos of A is equal to 5 squared plus 6.8 squared minus 9.1 squared all over 2 times 5 times 6.8. Okay, so cos of A equals, clear. Okay, I'm going to put everything in the numerator in brackets, so 5 squared plus 6.8 squared minus 9.1 squared, and divide that by 2 times 5 times 6.8, and I get negative 0.17014 dot dot dot. So angle A equals the inverse cos of that, and I get 99.79 dot dot dot. Okay, so I'll round that off later because I want to use all these decimal places to work out the rest of the work. Okay, so angle A then is 7963. Okay. All right, so next I'm going to look for, let's say, angle C. Okay, so 2 angle C. So cos of C equals A squared plus B squared minus C squared over 2AB. So cos of C equals A squared, which is 9.1 squared, plus B squared, which is 5 squared minus C squared, which is 6.8 squared, all over 2 times 9.1 times 5. So cos of C equals, in brackets, 9.1 squared plus 5 squared minus 6.8 squared, divided by 2 times 9.1 times 5, which is 0.676593. I want the inverse cos to find my angle. And I get that angle C is equal to 47.4219 dot dot dot. Okay, which I will round off later. Okay, so angle C then is 47.4219. Okay, so last angle to find is angle B. Okay, which I will just keep in mind that all angles in a triangle add up to 180, so I'm going to go 180 degrees minus 99.7963 minus 47.4219, and I get that angle B equals So, oops, 180 minus 99.7963 minus 47.4219, and I get 32.7818. Okay, so keeping in mind that my angles really aren't A, B, and C, angle S is equal to 100, right? That's the 99.7963 rounded off. Angle T is equal to 47 degrees, because that's the 47.4219 rounded off. And angle R is equal to 33 degrees, because that's the 32.7818 rounded off. Okay, and there your triangle is fully solved. And that's the end of this unit.